All right, I'm going to go over some of these fluids multiple choice with you just so you can understand how to do some of these. So I'll try to pick ones that are going to be relevant to the quiz. All right, so number one, it says two substances, A with a density of 2000 and B with a density of 3000 are selected for an experiment. If the experiment requires equal masses of each liquid, what is the ratio of substance A volume to substance B? So basically they just want you to get what is VA over VB. So in order to get those V's, you need to use the density equation. They don't give you the masses, but they do give you the densities. So for substance A, it's 2000, and then the mass we don't know, but we'll just call it M, and we're looking for VA. So if I rewrite this equation for VA, I get VA is equal to M over 2000. And if I do the whole thing with VB, it's 3000 equals M over VB. And if I solve for VB, I get M over 3000. So this is VB, this is VA, and they tell you in the problem, they want you to divide VA by VB. So M over 2000 divided by M over 3000. Now I know you guys don't love fractions, especially when it comes to doing division with them. But remember, when you divide by something, it's the same as multiplying by the reciprocal. So if I take this denominator here and multiply it over here by the reciprocal, so that would be 3000 divided by M. And so ignore this now because I just moved it. So that means that the M's cancel and I have 3000 divided by 2000. Okay, so 3000 divided by 2000 is just 3 over 2, so the answer is D. So let me just see how I can really quick clear this page. Hold on. Okay, for number 2, the density of a substance P, the volume is V, and the mass is M. If the volume is tripled without changing the density, what is the mass? So here's the equation. If the volume is tripled and density is constant, that means you must multiply the mass times 3 so that it cancels out and keeps the density constant. So the answer to 2 is C, 3M. For number 3, a perpendicular force is applied to a certain area and produces a pressure P. If the same force is applied to a twice bigger area, the new pressure on the surface is. So if you double the area, what you do to one side, you have to do to the other. So the answer is P over 2D. For number 4, there are two round tables in the physics classroom, one with a radius of 1 and the other with a radius of 2. What's the relationship between the two forces? So pressure is force over area, and the area of a circular table will be pi r squared. If you double the radius is squared, so that means that you have to square the double, which means it's times 4. So that means that you have to multiply this by 4. So if the area is multiplied by 4, then that means, and the force remains the same, then that means the pressure is a fourth of that. So if the same force is applied to a twice bigger area, the new pressure on the surface is quartered. So P over 4, which is E. Number 5 is about pressure varies with depth, which the equation for that one is rho GH. And yeah, so the only thing that matters is the height, and because the heights are all the same, then the pressures are all the same, so the answer is E. For number 6, what is the gauge pressure at the bottom of the pool 3 meters deep? The reason why they say gauge pressure is because you're ignoring the atmospheric pressure. So like here's the pool. The water causes a pressure here because of the weight of the water, but there's also the weight of the atmosphere pushing down as well. They're saying ignore that. Just tell me what the pressure is from that. That's why they say gauge pressure. So the way to find that is just by using this equation again. They don't tell you what the density is, but we can assume that the density of water is 1,000. That's on your equation sheet. We can also make G 10 because that makes it easy for us, and then 3 is the depth, right? 3 meters is the depth. So when you multiply that together, you get 30,000 pascals. So number 6 is D, 30,000 pascals. Number 7 is not going to be on the quiz, but the following scientists that invented the mercury barometer, I believe that was Torricelli or Tortellini, however you want to remember it. Number 8, a car driver measures tire pressure to be 220 kilopascals. What is the absolute pressure? So the equation for the absolute pressure is equal to the gauge pressure plus the atmospheric pressure. The atmospheric pressure is 101 kilopascals. That's given to you on your equation sheet. And the gauge pressure is the pressure that you read on your tire gauge, which is 220. So that gives you 321 kilopascals, in which the answer is A. For number 9, a hydraulic lift in the small piston has an area of 2 centimeters squared, and a large piston has an area of 80 centimeters squared. What is the mechanical advantage of the hydraulic lift? Mechanical advantage just describes that idea where we can put in a little bit of force and get out a lot of force. And the way that you would solve that is basically just looking at the forces. So it's basically F2 over F1 is what you're looking for. But the easiest way to do that is just to divide the areas. So I'll show you. So pressure is equal to force over A, and the pressure that you get in is equal to the pressure that you get out. That's Pascal's law. So F1 over A1 equals F2 over A2. So we're looking for F2 over F1. So what I can do is I can swap these, and I can just say this is F2 over F1, and then this will be A1 over A2. So if you just divide the areas, you get the mechanical advantage. So the areas are 80 centimeters divided by 2 centimeters. So 80 divided by 2 is 40. And that's the mechanical advantage. For number 10, a hydraulic lift is used to lift a car. The small piston has a radius of 5 centimeters and the large piston has a radius of 50. The driver applies a force of 88. What's the weight? So we're using the same idea. The pressure in equals the pressure out. And so that's F1 over A1 equals F2 over A2. And F1, they tell us, is 88 newtons. And the first area is pi times 0.05 squared. 0.05 is the radius in meters. So that's why I converted that. And then we're looking for F2, and it's pi times 0.5, because that's 50 centimeters squared. When you do the math to find that, you get that the force is 8,800. Basically, you can cancel out the pi's on both sides and then just do all the math. Let me just double check. So this is how I would do it algebraically. I would cancel the pi's. I would do 88 divided by 0.05 squared, and I get 35,200. And then I would multiply that by 0.5 squared to get F2 by itself. And yes, I get 8,800. So you have 3 blocks of equal volume are completely submerged in the water. The blocks are made of different materials, aluminum, iron, and lead. Which of the following is the correct statement about the buoyant force on each block? This is a trick question. The buoyant force does not does not depend on the thing that you're submerging. It depends on the fluid. So if we're submerging them into water, the buoyant force is always just going to be rho Vg, where rho is 1,000, the density of water is 1,000, and if they all have the same volume, it says equal volume, we'll just call it V. If they're all the same V and G is always 10, then the buoyant force is actually constant across the whole thing. So the answer is D for 11. Number 12, a piece of iron has a weight of 3.5 in the air and 2 when it's submerged. What's the buoyant force? Well, just a quick force diagram. When you have it submerged in water, the gravity on it is going to be equal to when it's in the air, right? So the spring is reading, we'll call this F spring for the spring. The spring scale is reading 3.5 in air because that's the weight of the object. But then when you submerge it, the weight is still 3.5, but it appears the spring is doing less work because there's also a buoyant force. So the buoyant force is going to be the difference between what the scale is reading and what the actual weight is. So the scale is reading 2 newtons on this one. So that means 3.5 minus 2 means 1.5. So the buoyant force must be 1.5 in order for this thing to be at rest. So C is the answer for that one. For number 13, they say that physics students use a spring scale to measure the weight of a piece of lead. The experiment was performed 2 times, one in the air, the other in water. If the volume of lead is 0.0005 meters cubed, what is the difference between the 2 readings in the scale? Here's what you need to know from this problem. The difference between the 2 readings in the scale is always going to just be the buoyant force, because that's what the difference is. You're either submerging it or not, and so you're either exerting a buoyant force or you're not. So the buoyant force is just equal to the density of the fluid that you submerge it in, the volume of the fluid that's displaced, and G. So the density is always 1,000. The volume, they told us, is 0.0005, and G is 10. So 10 times 1,000 is 10,000. 10,000 times 0.0005 is 50. Or no, actually, 5, right? Sorry, I can't do math. Yeah, so 10,000 times 0.0005 is 5. My bad. So let's erase this. Just 5. Okay. Number 14. A wooden block with a weight of 7.5 is placed on water. When the block floats on the surface of the water, it is partially submerged in water. What is the weight of the displaced water? So here's the water. When you put something in water and it floats, sometimes part of it is submerged in the water and the other part is not. But here's what you need to know. The force diagram for this thing is going to be gravity pushing down and buoyancy pushing up. And the buoyancy is equal to the weight of the water displaced. Right? It says, what is the weight of the displaced water? It must, so if this is 7.5, then this must be 7.5 because it's at rest. So that's your answer, 7.5, which is E. I think the easiest way to look at number 15 is to just see that the density is 800 and the density of water is 1,000. So when you put an object that has a lower density than water in water, it will float. And depending on what the density is how much of that thing will be submerged. So it's just going to be 800 divided by 1,000, which is 4/5. So E. For number 16, a wooden block with a weight of 9 newtons is placed on water. When the block floats on the surface, it is partially submerged. So it's kind of like the last one we were looking at earlier. What is the volume of the displaced water? You're just going to, so you know that the buoyancy force is 9. And buoyancy is equal to rho Vg. And so if the buoyancy is 9 and the density is 1,000 for water, and you're looking for volume and G is 10, you would just solve for volume by dividing 9 by 10,000. And so 9 divided by 10,000 gives us 9 times 10 to the negative 4, which is E. The last one I want to go over is number 17, and that goes over this. A1 V1 equals A2 V2. If you double the radius, remember this is a circle, so if you double the radius, that's going to 4 times the area. So if you 4 times the area, I gotta stop.